So we're going to look at a specific type of question, finding the greatest coefficient or the greatest term, depending on the question. But basically, both ideas are exactly the same. And it comes from this very simple idea. If term k plus 1 is greater than term k, then term k plus 1 is the greatest term. So if something's bigger than the other, it must be the greatest thing. But then what we do is we create an equation which will then compare every term next to each other and thus come up with the overall greatest term. So the expansion of 2 plus 3x to the power of 20, we want to find the greatest coefficient. And I want to expand the whole thing out. So the general term k plus 1 would be 20ck, the 3x to the power of k, so therefore 2 to the power of 20 minus k. This might now explain to you my logic of why I do it that way. I want the term before it as well. So term k would be 20ck plus 1. 3x's to the power of k minus 1. The two have to add up to give 20, so therefore the power of 2 is 21 minus k. Okay. So then I just start with that statement. Well, if term k plus 1 is bigger than term k, then term k plus 1 is the greatest term. I put or equal to in there because it is possible you could have two terms with the same coefficient, two consecutive terms. So let's substitute into that little expression. It looks horrible, but it's actually quite nice. I'm going to move everything over. So divide by the right-hand side, and I'm simply going to solve this thing is greater than or equal to 1. Now, I've got to break up my 20ck's and so on into factorial notation. So 20ck would be 20 factorial on k factorial, 20 minus k factorial. Dividing by the 20ck minus 1. So I've inverted and multiplied. 20 factorial on the bottom, k minus 1 factorial, 21 minus k factorial. Now, how do I work out the number? Let's have a look at the top line here. I've got 2 to the power of 20 minus k, 2 to the power of 21 minus k. Now, I don't know what k is, but I do know which one's bigger. The higher power must be the bigger number. So they differ by 1, therefore they would cancel to leave 2 on the bottom. And then I look at the 3's and do a similar thing. Well, I've got power of k minus 1. Well, power of k must be the bigger one. They would cancel, leaving 3 on the top. Now let's play with the factorials. I do a very similar thing. Obviously, the 20 factorials will cancel. The k factorial and the k minus 1 factorial, again, I don't know what k is, but I do know k factorial will be bigger than k minus 1 factorial. And they differ by 1, so they would cancel, leaving k on the bottom. 20 minus k factorial, 21 minus k factorial. Well, 21 minus k must be the bigger one, so they would cancel, leaving 21 minus k on top. Now I've got a very simple inequality to go and solve. So 63 minus 3k greater than or equal to 2k. We end up k less than or equal to 63 and 5. But of course, k has to be a whole number. So I'm looking for the first whole number that satisfies this. 63 and 5, 12 and a bit, isn't it? So k equals 12 would be my solution. Now remember, it's not the 12th term, because we said term k plus 1 would be the bigger. So it's the 13th term, which is 20c12, 2 to the power of 8, 3 to the power of 12 would be the coefficient. So that would be the greatest one. The interesting thing is sometimes in the wording of these questions they'll say, which term has the greatest coefficient? Is it okay just to say the 13th term and not actually write the answer down? I don't know. I just like to play it safe, and I'll put the actual answer down as well. And so if that had turned out to be a whole number, so say it was 60 on 5 instead of 63 on 5, then that's when you're looking at a situation where two consecutive ones would be the same. The one where it's equal and the one where it's less than as well. What's the difference between finding the greatest coefficient and finding the greatest term? Well, the only difference is if you want to find the greatest term, they need to give you a value for x to substitute into, because we're not just concerned with the coefficient now, we're talking about the overall value. but I'll do it exactly the same way. I'll come up with a general term, but I've substituted in x equals a half. So you notice instead of having 3 to the power of 15 minus k there, I've got 3 on 2 because x was a half. And the term before it, oh yes, the negative. You'll notice in the 4 I haven't bothered with the negative 4. If it's odd, it's going to be negative. If it's even, it's going to be positive. When we're talking about the greatest, we're talking about the magnitude of the number. I'm not actually concerned with plus or minus. Okay, same statement. If term k plus 1 is greater than or equal to term k plus 1 would be the biggest. So put it in, as I say, exactly the same as the last one. So let's divide and get it greater than or equal to 1. Okay, so I've got 15 factorial and k factorial, 15 minus k factorial, and the other one 15 factorial, k minus 1 factorial, 16 minus k. Now sorting out the numbers, 16 minus k is the bigger, so 3 on 2 is on the bottom of the fraction, and 4 is on the top because k is bigger there. So now let's play around with the factorials. 16 minus k is bigger than 15 minus k, and k is bigger than k minus 1. So all up, I get 16 minus k on k and times 8/3. So 128 minus 8k. So this time I'm looking for the first one, 128. 121's 11 11s, isn't it? So 11 looks like our answer. And so the 12th term, which is 15c11, 3 on 2 to the power of 4. In this sort of one, I'm not going to leave it like that because I can still play around, because 4 to the power of 11 I can rewrite as 2 to the power of 22. And then 2 to the power of 4 is on the bottom, so the 2 to the power of 4 cancels into the 2 to the power of 22, and that's why I've just got 2 to the power of 18 there. So if I do notice they have a common base, I'm going to tidy that up, make it look a little bit neater. All right, 5e.